Hi, Assalamualaikum and good day to all my panels. My name is Wan Nurul Syahirah binti Azmi. My supervisor is Dr. Zarina binti Shamsuddin, and today I will present about my bachelor degree project 2 entitled Theoretical Prediction of Reclaimed Carbon Dust Filler or Mechanical Properties of Sheet Fabric Composite. As a recap from my FYP1, for introduction, the sheet produced by a silkworm that has a good mechanical properties but it is expensive. So the main concept is to reinforce the sheet composite with the filler to balance the properties of the composite. Sheet is selected because it has potential to be used as a reinforcement with other applications. The mathematical approach and ANSYS simulation will be used in the study to predict the mechanical properties of sheet reinforced carbon dust composite. For the problem statement of my study is first, we know that silk is expensive and carbon dust is a waste from the carbon fiber. So I need to predict the suitable amount of carbon dust that will be reinforced with the silk, and it is involving formula and calculation. The second problem is analyzing the relationship of fiber and filler loading through analysis and ANSYS. Okay, for the objective of my study is to predict the influence of carbon dust at different filler loading on the mechanical property of sheet reinforced composite using mathematical approach. And the second objective is to analyze the correlation between the filler loading on the performance using ANSYS simulation. For the scope of my study is the sample is composite with unidirectional fiber and layer of sheet fiber and carbon dust. And then the sample will be reinforced with 4% volume percentage of filler loading, which is 10%, 20%, 30%, and 40%. And the outcome of the correction in the reduction of layer of sheet and replaced with the carbon dust. Okay, at first, my study was based on experimental, but due to the pandemic, I need to change into a theoretical and simulation. So yeah, this is a close solution to carry on with my objective. At the right side is top is my flowchart of my study. It show that the flowchart of my study. Okay, material involved in this study is sheet fabric, carbon dust, and epoxy resin. Okay, below is then we proceed to mathematical calculation. Below shown the formula equation that involved in my study that I will calculate using mathematical calculation. All of the properties stated, and then proceed after I'm done with mathematical calculation, I proceed with the ANSYS simulation. Okay, continue to the result and discussion where it show this is the selected data that I collect from many study, from article and research. This is the final data that I collect. After I have go through all the study, and then this table show the volume fraction of each material. We are reducing the sheet fiber and increase the amount of carbon dust. The epoxy resin is same for each sample. Okay, first mathematical calculation that I calculate is on density. Okay, it show that in this table, it show that increasing amount of volume fraction filler loading that used, resulting in resulting the increased value of density of composite. Then for next the elastic modulus, or we usually call as Young modulus, or also tensile modulus. Also, increasing amount of volume fraction of filler loading increase, resulting in increasing value of elastic modulus. It shows that each of the sample has 22% improvement on each sample. And then proceed to tensile strength. Increase in adding 10% of filler content separately make the composite escalate up to 120% improvement in each sample. Also the increasing value of tensile strength. And next is the estimate strength of each material, fiber, reinforcement, and matrix. And then last I calculate is impact strength. The force that apply on this study is from 5 kN to 30 kN. It's applicable for automotive and aerospace application. Also, in this table, it shows that increased mass that apply, resulting in increased value of potential energy and impact strength. And then we continue to the result discussion of ANSYS simulation. At the end of this result discussion, I will compute all the value on a table to get a better view. For the simulation, for static structure, I apply two analysis that use, which is static structural and explicit dynamics. The boundaries they apply, boundaries condition they apply in the static structure is fixed support and force apply on both side. Okay, the first analysis in 10% volume pressure of pillar loading, it showed that total deformation using dot bone sample, using standard ESTM D138 standard, it showed that dot bone sample, this is a total deformation analysis. It showed that this red region is the maximum deformation occurs, while the blue is the minimum deformation occurs, because it was the fixed support that has been applied. And next is showed, this graph also is for total deformation. And next is the equivalent stress analysis. They show that this is the maximum value of this analysis because it has the maximum stress. This is the necking area of the dog bone sample. This also the graph of stress strain graph according to SM International 2004 plastic deformation, where the stress has been applied to the sample will elongate and it will reach failure and not recover back to its shape. This is a plastic deformation occurs, not elastic deformation occurs. Okay, next analysis on 20% volume fraction of pillar loading. It show this approximately like the previous analysis, but different value of deformation. It decreased amount, slightly decreased from the previous analysis. Also, it showed that higher deposition of carbon dust particles contribute to deformation and strength of the composite. But the stress on this volume fraction is still the same. It does not show any differences between the previous analysis. Okay, the next analysis on 30% volume fraction of pillar loading. It showed that slightly decreased amount of deformation from the previous result. The equivalent stress is still the same. For the 40% volume fraction, which is the highest volume fraction, it showed that maximum value is achieved, but it is slightly decreased from the previous sample because dispersion of carbon dust on this sample, but the equivalent stress is still the same and have no improvement. For next, continue to the explicit dynamic analysis on impact strength. This is using car crash simulation. This analysis is 10%. Look at this area. This is a red region, which is the maximum value, maximum deformation that occurs. And then this is a stress that apply. And the highest value stress is was at the peak, which is 480 megapascal. And then analysis and 20% volume fraction is show that from the red region, red area at this top of car reduced to turn to orange. It show that decreased value of deformation occurs between those two analyses. Prove that increasing usage of pillar loading can withstand a little deform when impact occurs. And this the equivalent stress that apply. It also decrease value of stress. And 30% of volume pressure of pillar loading show that from the yellow it turned to from the orange region it turned to yellow, which it show that the deformation is decreased also, and the equivalent stress also decreased. For the highest amount of volume pressure users of pillar loading, which is 40%, they show from the yellow it turned to green, also resulting in decrease value of deformation occurs. Then the 40% of pillar loading show optimal impact properties with less composite breakage, pull out, and debonding. And then this is equivalent stress also decrease value of it. And the comparison between of the result of between mathematical approach and ANSYS simulation from the discussion above, there is slightly different between those two results. In mathematical approach, it shows that increasing value of all the properties shown, but in ANSYS simulation, it shows that decreasing value of each deformation and stress applied. Because the filler content that used is increased. We know that carbon dust has a great mechanical properties. So it support the impact and does not the car does not deform too much from the usual. And then as a conclusion, the first objective is achieved because we are using mathematical approach, and all the data and result is increasing. It may resulting a composite may a great opportunity to create the material in the future. And the second objective is to analyze the correlation between the field loading and the performance using ANSYS simulation, where all the sample have been run in the simulation for resulting in deformation and stress. And for recommendation, ANSYS is so broad and wide of feature that I can discover. For to get an accurate data on seed rainforest, it is encouraged to do experiment on this composite as it can give a better result on this study. For sustainability, we are using a reclaimed carbon dust. It is from waste of carbon fiber. By using this recycled material, it can absorb the potential of waste via studying, calculation, and modeling. And long life learning, the study implementation of the potential waste in high technology application require a long time to learning on how to use ANSYS simulation. A new skill, experience, and knowledge in learning this software will be helpful in the future. And for the complexity, using these two approach to determine the whether the mechanical properties had an improvement or vice versa. Those two approaches may require many data and trial tests in order to get a desired result in mechanical properties. Okay, that's all. Thank you.